this video helpful, please like, subscribe and press the bell icon for notifications. Today in complex numbers, we will be proving some properties of conjugate. So our first property is conjugate of conjugate z is equals to z. So to prove that, let z is equals to a plus bi, then its conjugate will be a minus bi. Now the conjugate of conjugate z will be conjugate of a minus bi, and that is a plus bi, which equals z. So conjugate of conjugate z is equals to z. A second property is conjugate of z is equals to z if and only if z belongs to real number. So let z is equals to a, where a is pure real number. Then a can be written as a plus 0i. Then its conjugate will be a minus 0i, which is a, and that is equal to z. So we can say that conjugate of z is equals to z if and only if z is pure real number. Third property is conjugate of z is equals to minus z if and only if z is pure imaginary number. So let z is equals to bi. Bi is pure imaginary here. So bi can be written as 0 plus bi. So its conjugate will be 0 minus bi, and bi is z. So it will become minus z. So therefore conjugate of z is equals to minus z if and only if z is pure imaginary number. Now a fourth property is conjugate of z plus w is equals to conjugate of z plus conjugate of w. So let's take z is equals to a plus bi and w is equals to c plus di. Now left hand side will be conjugate of a plus bi plus c plus di. Now add the like terms, a plus c plus take I common, so b plus di. Now we need to take the conjugate of this complex number, and which will be a plus c minus b plus di. So open the brackets, then we will get a plus c minus bi minus di. Now we can put a and minus bi together and c and minus di together. So now we know that a minus bi is the conjugate of z and c minus di is the conjugate of w. So therefore conjugate of z plus w is equals to conjugate of z plus conjugate of w. Our fifth property is conjugate of zw is equals to conjugate of z times conjugate of w. So let z is equals to a plus bi and w is equals to c plus di. Then left hand side will be conjugate of a plus bi times c plus di. Now multiply, and we will get ac plus adi plus bci plus bdi square. Now put the value of I square, which is minus 1. So we will get AC minus BD plus AD plus BCI. Now the conjugate of this complex number will be AC minus BD minus AD plus BCI. Now right hand side will be A minus BI and C minus DI, because these are the conjugate of Z and W. Now again put the value of I square, that is minus 1. Then we will get AC minus BD minus AD plus BCI, and which equals left hand side. So conjugate of ZW is equals to conjugate of Z times conjugate of W. Our sixth property is conjugate of z to the power n is equals to conjugate of z to the power n. For this, let n is equals to 2, then left hand side will be z conjugate of z square, that is a plus bi square, so which will give us conjugate of a square plus 2a bi plus I square b square. Put the value of I square here and we will get conjugate of a square minus b square plus 2a bi. Now take the conjugate of this, it will be a square minus b square minus twice abi. Now right hand side will be conjugate of z is a minus bi, so a minus bi square will be a square minus 2abi plus b square I square. Again put the value of I square here, so we will get a square minus b square minus twice abi, which equals left hand side. So conjugate of z to the power n is equals to conjugate of z to the power n. Now we have to prove that z plus conjugate of z is equals to 2 times real part of z, that is rez. For this, let z is equals to a plus bi, then its conjugate will be a minus bi. Add them, we will get a plus bi plus a minus bi, and bi got cancelled, so it's 2a. And what is a here? A is the real part of z, that is real part of z or rez. So therefore z plus conjugate of z is equals to 2 times rez, or rez is equal z plus conjugate of z by 2. So here we just wrote rez for a. Similarly, we can prove that z minus conjugate of z is equals to 2i imaginary part of z, I am z. Now for that, again z is equals to a plus bi, then its conjugate will be a minus bi. Now z minus conjugate of z will be a plus bi minus a minus bi. If we open the bracket, then a got cancelled, then we will get 2bi. And what is b here? B is the imaginary part of z. So we can write I am z for b here. So therefore z minus conjugate of z is equals to 2i am z, to 2i times imaginary part of z, or I am z is equals to z minus conjugate of z by 2i. A ninth property is z times its conjugate is equals to a square plus b square. So for that, z times conjugate of z will be a plus bi times a minus bi, which will be a square minus bi square, because it's in the form of a plus b times a minus b, which is a square minus b square. So we will get a square minus b square I square. Now value of I square is minus 1, so a square plus b square. Therefore z times conjugate of z is equals to a square plus b square, or z times conjugate of z is equals to mod of z square, because we know that mod of z square is equals to a square plus b square from the modulus formula. Today in properties of conjugate, we proved few properties by taking two complex numbers z is equals to a plus bi and w is equals to c plus di, and proved that conjugate of conjugate z is equals to z and conjugate of z is equals to z if and only if z belongs to real number, and conjugate of z is equals to minus z if and only if z is pure imaginary number, and conjugate of z plus W is equals to conjugate of Z plus conjugate of W. Conjugate of ZW is equals to conjugate of Z times conjugate W. Then conjugate of Z to the power n is equals to conjugate of Z to the power n. Then Z plus conjugate of Z is equals to 2 times REZ, or REZ is equals to Z plus conjugate of Z by 2. Similarly, Z minus conjugate of Z is equals to 2I imaginary part of Z, or imaginary part of Z is equals to Z minus Z conjugate of Z by 2I, and then Z times conjugate of Z is equals to A square plus B square. Our next topic will be properties of modulus. Thanks for watching.